welcome back to StudyOnion, and today we're going to be talking about sidereal and synodic time. Let's get started! So before we begin this chapter, let's just refresh our memory on some of the key points that we've learnt before that will be crucial. 1 year corresponds to one complete orbit of the Earth around the Sun. And during this time, the Earth spins on its axis 365.25 times, and one sidereal day corresponds to the time taken for the Earth to spin once on its axis, and that is equal to 23 hours and 56 minutes. One solar or synodic day is 4 minutes longer at 24 hours and 0 minutes. Okay, so if we ignore precession, the Earth's axis of rotation remains fixed with respect to the stars, but not with respect to the Sun. During one solar orbit, the Sun lies directly above key latitudes on key dates, as shown in this diagram. The exact dates of this can vary each year by plus or minus 2 days. Now, the Earth's orbit around the Sun and its fixed axis of rotation explains why the Sun rises and sets at different times on different dates during the year. And it also explains the apparent motion of the Sun on the celestial sphere. And we'll be talking more about the celestial sphere in topic 6, celestial observation. And also why the altitude of the Sun at noon is different on lots of different dates. Now, close to the autumn and spring equinoxes, the days are roughly the same length. And the way that we can kind of remember this is by looking at the name. The Latin word equinoctial translates as equal night. And that is why we use the word equinox, equal night. Now, as spring advances, the days become longer, with the times of sunrise and sunset being gradually earlier and gradually later in the day. The Sun rises at its earliest and sets at its latest times on dates close to the summer solstice in June. And in December, close to the winter solstice, the reverse becomes true. So, the Sun rises at its latest and sets at its earliest. However, in the southern hemisphere, the opposite will apply, because the days will be longer in December and shorter in June. Now, in the UK, the Sun is low over the southern horizon at noon on December 21st, which is the date of the winter solstice. But on June 21st, the date of the summer solstice, the altitude of the Sun at noon is actually 47 degrees higher. So, let's take a look at a sample practice question. A synodic day, or a solar day, is 4 minutes longer than a sidereal day. Explain the reason for the difference. And this is a 2-mark question. So, pause, think about it, and then press play for the answer. So here is an example I wrote an A-mark breakdown. The Earth travels in its orbit around the Sun in the time it takes for the Earth to complete a full rotation of its axis. Then, the extra 4 minutes are used to rotate in order to realign back with the Sun. Okay, so let's take another look at another practice question. This one's slightly harder, so don't worry if you don't fully understand it, but I will explain it in just a minute. So, let's go. A student obtains some star trails for the stars which are close to Polaris. The mean angle subtended by these arcs was 28.9 degrees. The exposure time was 1 hour and 50 minutes. Calculate the length of a sidereal day in hours and minutes. So pause, take some time to work it out, and then come back and check if you're right. Okay, so what you first do is convert the time into minutes. So 28.9 degrees equals 110 minutes, or 1 hour and 50 minutes is converted into 110 minutes. So, to calculate the amount of time which the Earth rotates by in 1 degree, we do 110 minutes divided by 28.9 degrees, which gets an answer of around 3.8062 ... Now, to calculate the time it takes for one full rotation of the Earth, which is 360 degrees, we do 3.8062 ... times 360, which gives us 1370.242. And to calculate the sidereal day time in hours and minutes, we do 370.242 ... divided by 60, which gives us an answer of 22.837 ... And to estimate this into hours and minutes, it is roughly 22 hours and 50 minutes, as the 0.8 of an hour is actually 50 minutes. And you've got to be careful with that, because you don't want to give it as 22.83 minutes or anything along those lines. You have to make sure that you convert it into hours and minutes like I've done here, or just say 22.837 hours. So, to summarize, 1 year corresponds to one complete orbit of the Earth around the Sun. During this time, the Earth spins on its axis 265.25 times. One sidereal day corresponds to the time taken for the Earth to spin once on its axis, and that is equal to around 23 hours and 56 minutes, and one solar day is actually 4 minutes longer at 24 hours. The Earth's orbit around the Sun and its fixed axis of rotation explain why the Sun sets and rises at different times on different dates during the year, and explains the apparent motion of the Sun on the celestial sphere. Close to the spring and autumn equinoxes, the days and nights are roughly the same length, whereas when the spring advances, the days become longer, with the times of sunrise and sunset becoming gradually earlier and later, respectively, in the day. So hopefully you learnt more about sidereal and synodic time. I'll see you guys again next week for another video on time and the Earth, Moon, Sun cycles. But for now, bye!